look at a few properties of graphs, the first of which is the idea of increasing and decreasing. If I look at these two graphs here, in general, we read graphs the same way we read in English, from left to right. So for my first graph, as I move from the left to the right on this graph, I can see that my y values are getting bigger and bigger. This is known as increasing. As we move to the right, the y values are growing. For my second graph, as I move from left to right, I can see that my y values are shrinking. This is known as decreasing. As we move along our graph, our y values are getting smaller and smaller. Let's look at this graph here. And we want to figure out where it's increasing and where it's decreasing. Remember, we read graphs left to right. So as I start, I can see this graph is moving down. So that would be decreasing up until I hit this point here. So it's decreasing from negative infinity up to -1. And we use an open parentheses always rather than our square brackets for increasing and decreasing. Up until we hit this point here, so it's increasing from -1 to 1. Continuing along, we can see we go down again until we hit this point, so it's also decreasing from 1 to 2. And finally, after that, my graph is going up again indefinitely. So it increases from 2 to infinity. Next, let's look at this graph. We once again want to see where it's increasing and where it's decreasing. Starting on the left, I can see that the graph is moving down as I move to the right, up until this point here, 0, 0. So it's decreasing from negative infinity to 0. And after that, it is increasing indefinitely. So increasing from 0 to infinity. Next, I want to define a local maximum and a local minimum. Here is a graph example, but a local maximum basically in some kind of neighborhood, small neighborhood around that point, we'll say in here, it is the tallest point. For this one, I can draw this kind of little neighborhood around this point, and it will be the maximum y value in that area. You'll notice this second one is not the maximum of the graph, neither is the first one. But locally, right around that point, it is the maximum. The same thing for the minimum. If I look right around those points, they are the smallest y value around there. They're not the smallest in the entire graph, but locally, in this kind of little neighborhood around that point, they are the smallest y value. Let's go back to this graph. If I want to find a local maximum, I can see that that happens at this point here. Right around this point, everything is smaller than it. It is the tallest point in its area. So the local max is 0, because that's the highest y value in that area, and it occurs at x equal to 1. For my local minimum, I can see I have one down here, where in its region, it is the smallest value. That goes down to -2. And it occurs at the point x equal to -1. I have another one here that is a minimum value of -1. And it occurs at x equal to 2. So this graph has one local maximum and two local minimums. If I look at this graph here, I can see that I have a local minimum of 0, and it occurs at x equal to 0. However, There is no local maximum here. Both of these functions just get bigger and bigger indefinitely. So there's no point that in a little neighborhood, in a little area around that point, it is the maximum. This graph does not have any local maximums.
If you would like to see Professor Pierce make more videos like this one, you can support her on Patreon in the link below. Any and all support means a lot to her. It allows her not only to make more videos, but it also allows her to campaign for free and accessible online education to conferences and other universities. Thank you for watching, and remember, math is for everyone.